I'm Kohei Nakaji. I'm engineer in Smart News Inc. I'm developing the algorithm of news delivery algorithm. So using especially machine learning or natural language processing. Actually, my research background is not machine learning kind of thing, but elementary particle physics theory. So if you guys have some interest in physics, I can talk about it later. So today, I'm gonna talk about this topic: globally scalable web document classification using Word2Vec. Because this talk is based on the technology in smart news, first, let me introduce about smart news. So smart news is the company developing the iOS and Android application, smart news. How many guys use smart news here? Okay, very, very few people. Very few. Then, how many guys love machine learning here? Great, great, great. Then you will love machine learning. No, you will love smart news because smart news is made by machine learning. So smart news is news app for more than 100 countries, but there are no editors, no writers. Algorithms do everything. So how many guys uses news app every day? Not so much, actually. Yes, almost all of the news app fails. And some of the news app have great downloads, but they are annoying with low engagement ratio. Smart News has 10 million downloads globally, and more than 50% is active. So we can be a successful news app, right? So what makes us different? What is the difference between smart news and other news app? The key word is machine learning for discovery. Some news app uses editor. So they are not scalable and they can be biased. And some news app use machine learning, but they are using machine learning for personalization. We use machine learning for discovery. It is a difference. So we use machine learning algorithm to make people to discover or learn new things. It makes us different from other news apps. So our theory is that the algorithm for discovery makes our engagement ratio high. So let me do demonstration of our app first. Can you see? See? Okay. So when you open it up, you see top news here. So top news is latest, most important news, which is selected by our algorithm. So here, over here, you see tabs for each category. Entertainment, sports, lifestyle, US. Actually, this is the most straightforward result of our web document classification. And in this tab, you can see latest, most important articles for each category, which is selected by our algorithm. So you see that how precise our web document classification should be, right? If there is any mistake, it's bad, right? So yeah, this is a main topic of today. One of the cool things of our app is that, so when you find what you want to read, let's say you want to read this, you have Smart View option. You may like this option because it's clean and very simple. We also have web browser mode, and it is ordinary web browser. When you see article in web browser, there are so many things you don't want to read, right? Many ads, many banners, many links, so many things that you don't want to read. But in Smart View, it's very simple. There's no ads, no banners. You may understand how difficult to extract this Smart View from arbitrary web document, right? So I will talk about it later. So one another thing which is cool for Smart View is that we can read Smart View in offline. So you can read Smart View even in airplane or even in metro, anywhere you can read Smart View. So let's get back to the list. Okay, this is the end of the demo, and let's get back to the slides. So as I already told you, we have 10 million downloads and 50% is active. And we have 3 types of edition, Japanese edition and US edition and international edition. And in international edition, users can read articles in English in more than 100 countries, which is localized to each country. But again, there are no editors. Algorithms do everything. So UI is good. Smart View is good. But what, as I told you, what makes us different is our algorithm for discovery. So our algorithm to make people to discover new things. So this is the outline of our algorithm for discovery. First, URL is found from the internet signals, and HTML structure is analyzed. For example, the main text is extracted, or image is extracted, title is extracted. And after that, semantics is analyzed. For example, what category the article has, or what topic, what subject the article has, or what types of image the article has. It's not semantics, but we do image analysis also. And after that, by using the signals from internet and semantics, we calculate the importance score of each article for each category for each country. And after calculating the score of each article, we diversify the topic of the delivery list. We don't want to deliver the same topic article into one channel, so we do diversify the topic of the articles. And after that, we deliver articles to users. We crawl 10 million articles per day, 10 million URLs per day, but we only deliver 1,000 articles to users. The delivery list is refreshed in real time. So there are so many things to talk about this algorithm, but today, let's get into, and I will talk about it later. For example, probably how we do importance estimation. We do personalized, or we do another approach is probably especially important because this is related with our mission, algorithm for discovery. So I will talk about it later. Now, let's get into today's topic, web document classification. The reason why I choose web document classification today is that web document classification is very important for our application, as we already see. And for another reason, information retrieval from unstructured data document is probably a common task for many applications. So that's why I choose this topic today. So let's get into web document classification. The task definition of web document classification is very simple. So when an arbitrary web document arrives, choose one category exclusively from predetermined category set. Very simple, right? Choose one category to one web document. This is the topic. there are roughly 2 steps to do web document classification. Number one, main content extraction. We have to extract main content from unstructured data, from HTML. It is very difficult because there are so many websites, and each website have each different structures. Oh, you know, maybe you know. Yeah, so many different structures. So it's very important. And as we already seen, we have Smart View in our app, and for creating Smart View, this main content extraction is very important. And number 2, we do text classification. So first, I will briefly talk about main content extraction, and after that, I will talk about text classification by using the Word2Vec extended model. So let's start from main content extraction. So when we do main content extraction, there are 2 types of approaches. And actually, we used bottom one. The first one is extract after rendering whole pages. So after rendering CSS or JavaScript, images, all of the things. This approach is relatively easier because we can use the information of position or width or height of each component. So it's relatively easy. We can easily extract the main content. The second approach is extract main content directly from HTML. It's more difficult, but it doesn't cost much computation resource. Because we have to analyze 10 million articles per day, let's say 100 articles per second, so fast is important. So we use the second approach. So I will talk about it. So the example of main content extraction from HTML is like this. So detect which part is not main content and detect which part is main content. It's easy. So of course, it is possible. Rule-based approach is possible. Define rule like div which has text length more than 200 and number of A tags is less than 3 is main content, or rule 2, blah, 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 rule 3, blah, 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 rule n, blah, blah, blah. It's hard to define these rules. It's hard. And as I already told you, we have Japanese version, and we will launch another language version, and when we will do the same thing in another language. It's really hard, right? So rule-based approach is possible, but very hard, not scalable. So we are using a machine learning approach for doing this as one of the algorithm. So this machine learning approach is based on the paper in 2011. So so I will talk about it. I will talk about it. So in training phase, HTML is separated into each text blocks. And from each text block, feature vector is extracted. So let's see this block separation and feature extraction part. So as I told you, for step 1, HTML is separated into text blocks. And we can define, there are many options to define text blocks, but we use our definition of text block is the element which is sandwiched by block level tag. And after that, we define the local feature of every text block. For example, local feature like word count, in this case 36, or a number of A tag. In this case, this is 0, right? And after that, for step 3, we define the feature vector for each text block as the combination of local feature in other text block. In this example, feature vector for each text block is defined as the local feature of current block and previous block. This is a feature vector. So now we get the, so in the training phase, now we get the feature vector and labeled feature vectors. Labeled feature vectors. Label is main content or not main content. By using this labeled feature vector, we can train decision tree. When live data, real live data comes, new data comes. By using block separator and using feature extractor, a feature vector for each text block is extracted. And by using decision tree, the main content is extracted. Let's get into this part. So because we already got the feature vector for each text block, by using decision tree, from feature vector, a feature vector is classified into main or not main. So we can get, we can know which text block is main content and which text block is not main content. And by combining the result of these classification results, we can get the main content. So probably everyone know about this architecture, but let me review the overall architecture of text classification first. So in the training phase, we first prepare the document set, labeled document sets. And we, in our case, we prepare the document sets by crawling. First, we crawl the articles by our crawler, and our annotator annotate category to the document. And after that, in training phase, features are extracted, then the labeled feature sets are created. And by using training algorithm like logistic regression or SVM, classifier is trained. When the live data comes, by using the same feature extractor, features are extracted, and by using classifier, the category is obtained. This is a very simple overview of the classification. Because we use training algorithm, as training algorithm, we use logistic regression, and it's very common, and there are so many materials, so I don't talk about it today. And I just focus on this feature extraction part today. As a feature vector, bag of words is commonly used. Bag of words is a set of words in the document. Don't care about word order, very simple, but it's not bad. If we want to improve the quality of the, let's say, precision of text classification, we add, for example, stop words, or we add some dictionary, or we add TF-IDF, like that. In Japanese, it is similar. We have to, because Japanese is not space-separated language, we have to use some technique to separate each word. But after separating each word, the situation is similar. We use bag of words with some feature engineering. But bag of words is definitely the perfect feature vector, right? Definitely not perfect feature vector, right? Because, for example, it doesn't care about word order, or it doesn't care about semantics. For example, the distance between sports and soccer is the same as the distance between sports and machine learning. So, so we wonder if there is better feature vector or not. And we use paragraph vector as another option for better feature vector. And paragraph vector is Word2Vec extended model. It is better. Better means the precision, text classification. Precision in text classification is better. So we use paragraph vector. So let me introduce about paragraph vector. The example is like that. So every document is mapped into the dense, several 100 dense vector, mapped into dense vector. So because paragraph vector is Word2Vec extended model, so let me first introduce about Word2Vec, and after that I will talk about paragraph vector. Word2Vec model, when we use Word2Vec model, every word is mapped into unique dense word vector. In paragraph vector case, as I told you, every document is mapped into unique vector. So let's first talk about Word2Vec. So every word is mapped to unique word vector. In this example, France, Paris, Germany, Berlins are mapped into unique vector. And what is surprising is that the feature like Germany minus Berlin equals to France minus Paris. It's surprising. By this nature, we assure that some semantics is embedded in the word vector. So the procedure to create word vector in Word2Vec is like this. So first we prepare for the sets of document and label each word W1, W2, blah, 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 like that. And after that, maximize the objective function L. In this objective function, large D means the number of words in the whole document. And C is arbitrary number, 2 or 3 is commonly used. Maximizing this objective function L means that maximizing the probability to predict a word from surrounding words. For example, in the light figure example, while training, the model is refreshed so that the probability to predict on from surrounding words, cat, sat, the street becomes higher. So as a probability function, this P is used. This P is used. Every word has inner vector V and outer vector U. And roughly speaking, after training converge, the more a pair of words shows up in one sentence, the larger the inner product of U and V for 2 words becomes. So after maximizing the objective function, we can get the optimized value of U and V for each word, W, and we use V as a word vector for W. And actually, technically speaking, to maximize this objective function L costs too much. The bottom part of exponential, the sum of W costs heavy, so we have to use some approximation. There are 2 types of approximation. One is hierarchical softmax, and one is negative sampling. But it's beyond the scope of this talk. So this is the way to create word vector by using Word2Vec model. Then let's get into paragraph vector model. So as I told you, every document is mapped into one dense vector. So the procedure to create paragraph vector is similar to Word2Vec case. First, we prepare for the document set, and we label each word W1, W2, blah, 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 like that. And we also label each document as document 1, document 2, like that. And we maximize the objective function L. The difference from the Word2Vec case is that the objective function includes the document ID, doc underscore I here. So maximizing this objective function means that maximizing the probability to predict a word not only from the surrounding words, but also from document itself. The model of probability function is like this, and it is also different from the Word2Vec one. Difference is that it includes a document vector here. So each word has, like Word2Vec case, each word has inner vector and outer vector, and each document has its own document vector. And we maximize L for U and V and W, and we can get the optimized value of U and V for each word, and D for each document. And we use D. D is a paragraph vector. But we get a paragraph vector for each document, but what we want to do is not this, because now we get the paragraph vectors for given document sets. That's not what we want, right? What we want is when new document comes, extract paragraph vector from document, right? So for doing this, we need another step. So after this process, maximizing L, and we get optimized value of U and V and D. When new document comes, we label the document like W1, W2 again, and then we maximize this LDoc, this object function, LDoc. We don't need to maximize this LDoc for U and V because we already have the optimized value of U and V. All we have to do is just maximize this function for D. And we get the optimized value of D, and this is the paragraph vector for the document. Probably it's a little bit complicated, so I draw a very simple picture here. So we put the large document sets into the into machine, and we train the feature extractor, and by using the feature extractor, when new document comes, paragraph vector is extracted. It's very simple, right? So yeah, it's a simple picture of training, getting the paragraph vector. For training feature extractor in our data set, we use 100,000 documents, and it takes, in laptop, it takes only 3 hours or 4 hours. It doesn't take much. And for extracting paragraph vector from new document, it takes only several milliseconds, so it doesn't take time. So after obtaining feature vector, paragraph vector, by using paragraph vector as a feature vector, we can do the ordinary text classification like this. I want to talk about the good point and bad point of using paragraph vector from the point of operation. The good thing is actually the high precision in text classification. In our data set, the precision of text classification is better than using backward words. So it's good. And for another thing, high scalability is very important because we don't need to work hard to do feature engineering for each language. All we have to do is just prepare the sets of documents. It's great. So in our use case, we use paragraph vector as by combining with the backward words classifier. So for example, in some use case, we use combination of each classifier, like use a more reliable result of two classifiers, backward words classifiers versus paragraph vector-based classifier. And our another use case is validation. Use one to validate the other result. And our future use case is we do it in multilingual localization. In multilingual localization, when we do that, we don't want to do feature engineering. We don't want to do work hard on feature engineering, right? So using only paragraph vector-based classifier is actually possible from the point of operation. It's really good. So this is the end of the text classification, and probably, yeah. Actually, we should search for that. We should try first. But actually, Japanese and English is really different, right? Probably it's good in French or Spanish. It's not so different from English. So yeah. I don't know about Arabic or Hindi. It's expectation. I didn't try. Actually, do nothing. Yeah. So for doing the, yeah, I'm doing that. We are doing that for backward words case. Actually, for Word2Vec case, we don't do anything. All we do is just separate each word by space. That's all. So this is the end of the text classification part. And now let me talk about our challenge. So as I told you, news is uncertainty seeking for long-term values. What if you keep hearing only opinions that match yours? Or what if parents don't feed vegetables for children who only likes meat? So what other big data company is doing is suggest what users already have interest, right? Using, for example, matrix factorization like that. we don't want to do that. What we want to do is make user to discover another thing. Discovery for our algorithm to discovery is what makes us different. But it's really challenging task, you know. So for doing that, we are developing first we have to get better feature vector for users and articles. For doing that, we are doing brushing up the topic extraction algorithm or image extraction algorithm like that. And for another thing, we are doing the algorithm to explore the user's interest space by using multi-arm banded algorithm-based scoring model. So actually, we have to create a model which includes 10 million feature vector of 10 million users and real-time feature vector of articles. It's challenging, I guess. Yeah, I'm sure that it's really challenging. It's really interesting task, not just do the matrix factorization. We have to create a model to explore the user's interest space, for example, by using banded algorithm. And we have to calculate this big data. So it's really challenging task, but we have only 5 engineers who tackle on this problem. There are many engineers, but who tackle on this problem is only 5 engineers, including machine learning PhD Rikia-san there, string theory PhD Nishio-san here, or Hidemasa is here. Where is Hidemasa? Is here, or Yuhei is here, and me, only 5 people. So we need much more people to tackle this problem. So we are hiring so much to tackle on this problem. So we need much more machine learning and NLP engineer, and we need more data science engineer. So it's our character, Chikyu-kun. So yeah. So feel free to contact me. And now, oh, this is Chikyu. And now, so finally we have CEO here. So please see how our CEO moves.
Hi, I'm Kaisei Hamamoto, the technical co-founder of Smart News. I'm so pleased we managed to successfully launch Smart News in the US with more than 1 million monthly active users after quickly growing in Japan. Now we have more than 10 million global users with 5 million monthly active users, and we regard machine learning as a big part of its growth. But please let me give a little context of how we think slightly differently about machine learning. A number of companies have been trying to take full advantage of machine learning in order to cater to each user's interest in consuming content. And as a result, users tend to easily fall into a pitfall of so-called filter bubble, as you know. And in the short term, it might be a good thing because it can maximize the time spent on their products and maximize the user engagement. But in the long term, especially when it comes to news, it might be a problem, we think, because we believe that the secret to getting news right is discovery, not personalization. So in other words, we need to solve a very difficult problem of exploitation and exploration trade-off. with the hope of delivering the quality news or quality information to the people who need it in the world. And we do that by machine learning. If you are interested, please talk to me afterward. Thank you very much.